is the center of distribution, and the standard deviation is the spread. So what I mean by the mean, it means where most of the values converge. That's what the mean is. And then the standard deviation is the spread of the data. So the higher your standard deviation is, the more your normal distribution graph will look peaked. The lower your standard deviation is the wider, is the more spread out your data will be. And it's the better. Because remember we were doing the question before and I told you that the reason why strategy 1 was more riskier was because it had the highest standard deviation. So the lower the standard deviation is, the better it is for you. So now we're going to look at how to calculate the Z-score. This is used, we normally use a Z-score when we're dealing with normal distribution. So the first thing we do is we begin with the value with x, which is a value of the variable x. So small x, which is a value of the variable x. And then we standardize using the formula z is equal to x minus mu, which we know is our population mean, divided by sigma, which is our population standard deviation. After we standardize our value, we have to write a probability statement about our z values, and then we solve for the probability using the table. So calculating the probabilities using the Z table. Remember that the Z table gives us everything to the left. So once we see anything less than, we know that we're directly into the table. So in this case, so the probability that capital Z is less than Z is equal to what you look up in the table directly. But suppose they ask us for more than or greater than or something like that. The probability of Z greater than Z is equal to 1 minus probability of Z less than Z. Because remember that the area under the graph should be equal to 1. Therefore, the probability of everything to the left plus the probability of everything to the right should be equal to 1. So in order to find the probability of everything to the right, you just minus the probability of the values to the left from 1. The probability that Z is equal to Z is going to be equal to 0. The probability that Z is less than or equal to Z is just equal to the probability that Z is less than 0, because Z equal to Z is equal to 0. And again, if they ask you the probability that Z is greater or less than Z, it's just going to be the probability that Z is greater than Z, because the probability that Z is equal to 0 is equal to Z is equal to 0. So we just write 1 minus the probability. And remember that because this gives us the value, remember that normal distribution has to do with continuous. So we don't have to have an exact value. We can find the decimal places. That's why when the probability of Z is greater than or equal to any value, we can just write it back without the equal sign. So the probability that Z is greater than Z is equal to 1 minus the probability that Z is less than Z, because remember that our normal distribution does everything that is to the left. The probability that Z is greater than A but is less than B is equal to the probability that Z is less than B minus the probability that Z is less than A. All right, so A says that a radar unit is used to measure speeds of cars on a highway. The speeds are normally distributed with a mean of 900 kilometers per hour and a standard deviation of 10 kilometers per hour. What is the probability that a car picked at random is traveling at more than 100 kilometers per hour? So the first thing we have to do is write down what we were given. So we know that we have a mean of 90 and a deviation of 10. Then we need to write down our probability statement. So what we're looking for, the question is, the probability a car picked at random is traveling at more than 100 kilometers per hour. So the probability statement is going to be the probability that X is greater than 100. After we do we need to standardize our value. So we know that the formula for standardizing our X value is X minus mu divided by our standard deviation, which is equal to, so we're going to be substituting the values into the equation. So X is 100 minus mu 90 divided by the standard deviation of 10, which is going to be 100 minus 90 is 10, divided by 10 is just equal to 1. After we find the standardized Z values, we need to write the probability statement for our Z value. So the probability statement is that Z is greater than 1. But we know that our normal distribution table will never show us the greater than sign. It only shows us everything that is less than. So in order to find the values for what is greater than, we have to do 1 minus the probability that is less than 1. And we can look in the table. So this is positive table. You can look in the positive table for 1, which is right here, and we get 0.8413. We get 0.8413, and we put it in, so 1 minus 0.8413 is equal to 0.1587. So the probability that Z is greater than 1 is equal to 0.1587. This can be represented on a graph where the center right here is going to be 0 in this case. Remember, the center is not always 0, but when we're normally doing normal distribution, the center is 0. Our Z value is 1, and the shaded region right here represents our probability of 0.1587. All right, so this question says now a continuous random variable X is normally distributed with a mean of 100 and a variance of 80. Find the probability that X is between 85 and 112. So the first thing we're going to do is write down what we were given. So we know that the mean is 100, but there's a trick to the question. They gave us the variance instead of the standard deviation. So now we have to work out the value for the standard deviation. So we know that the mean is going to be 100, and the variance, which is sigma squared, in order to get our standard deviation, we have a variance. We have to find the square root of our standard deviation of our variance to get our standard deviation. So the square root of 80 is going to be 8.9443. Again, guys, I will always urge you to try to round up to 4 decimal places once you can. Trust me, it affects your results. Next, we need to write a probability statement. So the probability is that X is between 85 and 112. We know that now we need to standardize our values. So for our formula to standardize is X minus mu divided by our standard deviation. First, we're going to solve for Z lower. So Z lower I might just I'll try to fix the PowerPoint and then try to get an email to you guys. Alright, so Z lower is equal to, we're going to substitute our values, which is 85 minus 100 divided by 8.9443, which is 85 minus 100 is negative 15 divided by 8.9443, which is negative 1.68. When we're standardizing our values, that's where we'll always round off to 2 decimal places. Our Z upper now is going to be X equal to 112, which is 112 minus 100 divided by 8.9443, which is equal to 112 minus 100 is 12 divided by 8.9443, which is equal to positive 1.34. After that, we're going to write the probability statement for our standardized Z values. So the probability statement is that Z is between negative 1.68 and 1.34, which is equal to the probability that Z is less than 1.34 minus probability that Z is less than negative 1.34. Pardon? So this is equal to the probability that Z is less than 1.34 minus probability that Z is less than negative 1.68. Again, we can look in our normal distribution tables for these values. So for negative 1.68, you can look in your negative table. So you look along your y-axis first for negative 1.6, and then you can look along your x-axis for 0.8 and look where they intersect